Thanks for your patience. Okay. So let's look at the quick history that when you look at the 1980s and prior to that, most of the systems were very large and they were centralized. They had the mainframe and everything was connected to that central. You usually had a single vendor managing that, and usually your developments took a long time to do so. It was single platform, and usually the systems were run by mostly the experts, computer experts. And at the time, product reliability and quality, they said was expected. However, there were still many problems at that time. You may have heard of software crisis. Who remembers what we mean by software crisis? So most of the systems, let's say, either were not delivered with the required requirements, or they were not delivered on time, or within budget. So many of the systems which were out there in the industry had major problems. And if you go back, if you study the Software Engineering Institute's work, they came up with some models to help with some of the software crisis. But basically, software crisis refers to the situation where the software products were either late, or they were far beyond the budget, or they were not delivered with the right quality or the expected requirements. Now, when you go to 1990s, then that's when the PCs and this desktop computing came about. So each individual could have their own PC. Multiple vendors were involved in developing a software, then they could integrate all these different systems. You had a faster or shorter development time. Rather than waiting for, let's say, 2-3 years before you can see a software product, you could see something in a shorter 1 month, 2 months, or within a reasonable amount of time. And then systems could be run by the non-computer individuals. It wasn't too technical. And then at that time, a new product was fashionable. The people, you may remember, or you may have read about .com era. No matter what idea you came about, that a software, you could make lots of money at that time. So you kept on producing product for the market. And reboot became acceptable. Anytime, even right now, you hear that anything happens, okay, go ahead and shut the machine off and turn it on. It's going to fix the problem. Still, we're accepting that kind of low quality from the software. My own smartphone, anytime I have a problem, when I call the customer support, they say, please shut it, turn it off and turn it on again, see if it fixes the problem. If not, call us back. So that's indication of what kind of quality you are dealing with. And then in late 1990s and 2000s, that's where we are, then web became available to large number of people. And then again, at this time, we are looking at the product reliability and quality. And especially, you know that security is becoming a big issue these days. And people who are in that field, they can make lots of money. Can you give me some examples of security requirements in some fields? Like what? Good. And what about some other applications that really security is becoming so important? Oh, you're getting on Wi-Fi, right? That's by itself a joke these days, especially if you're in the public places to use the Wi-Fi systems. Or again, with the automation of the healthcare information, security is becoming a very high priority. That's another area that all of our healthcare information is going to be on the system. How secure are they? Can the people get access to all our history, medical history? As part of the security, yes, you got to go through some kind of a strong type of encryption mechanism to secure the data. So you see that as the history has passed, how we started with the product reliability and quality, then we kind of let it go around this era, and then we are going back to it at this time. Right now, as you know, speed to market is very important. The faster you can produce your product, the better chance you have to win the market. Also, unfortunately, there are many small organizations that cannot afford good testers to help them out with production of the quality software. And no wonder still you are going to see so many low-quality products out there. Many organizations have started using Agile. How does Agile work? Can somebody very briefly mention what Agile development methodology looks like? Mm-hmm. Okay. Okay. Yes. Mm-hmm. Okay, good. We are putting all of this together to come up with the overall definition. Yes, so far so good. You're addressing the elements. Yes. Mm-hmm. So you're developing your software in an incremental basis. Normally every 2 to 4 weeks, you're going to have a running program that you can demonstrate to the user, to the client. Now, what do you think about the quality? Has this one decreased the relative level of the quality when you compare it with traditional software development? How has the quality suffered, if any, using Agile?
Pretty much the same because you're able to take a microscopic view of each level. You're able to see what wasn't implemented and what was, and you can make those changes more quickly. Whereas the other ones were a little bit better. They were good as well because you had a very big view of what everything was going to look like before you got into any cooking at all. So some of those things that you might accidentally repeat in the Agile method, you were not going to do in some of the older products.
When you follow Agile methodology, you know, some organizations, they say we are Agile, but they're doing ad hoc software development, which is different from Agile methodology. So those that are going to just use the Agile name to just do their ad hoc development, they're going to have a very low quality product created. But if you really follow, as you mentioned, Agile methodology, every 2 or 4 weeks, if you have any problems with the system, you can catch it very quickly, and then for the next 2 or 4 weeks, work on those problems. So you can really, it can help you with increasing the quality or delivering what the customer is looking for. Now, for some time, testers were really low quality, and not low quality, that's not the term I want to use. They were not as respected in an organization, a development organization, as I can probably say these days because of the really importance of the testing and quality assurance on the product. And testers have a good opportunity to really grow in the organization. Testing to the training to business analysis position and so on. But unfortunately, some organizations may not put that much really emphasis on training the testers. And hopefully, again, we're going to give some good ideas of what testing is about and what different techniques exist in testing, that you can be great testers when you go to the real world. You work where do you work at? Oh. So do you have a different testing group, or?
I have an intern in my team which peer reviews my code. If I can't figure it out, I'll back.
And eventually, what happens to that product? You just roll it out? Is there a group?
It's internal applications.
Oh, that's internal. Okay, but it's still for that internal. As soon as you develop it, just you do the unit testing and all that, and you roll it out. You can also, these days with the improvements in the tools and technology, you can create a better product like the IDEs that have so many integrated debugging mechanisms, debugging tools can really help you with creating a better software. When you ask people what is quality, you may see different answers. So quality from my perspective may be different from your perspective, and so on. Let's say if you ask a person who's in marketing the product, what is quality? Versus somebody who has developed the code, developed the system, what is the quality? Or the client, what is the quality?
The salesperson might be how many clients that have brought in, might be quality to them, whereas to a developer, it might be the quality of the code. There's no execution errors. It works perfectly exactly as it was asked to be done.
Yeah. So that's why anytime you develop a code, you got to really come up with some criteria of how you can measure the quality of that product from different perspectives. And you've got to see which perspective is more relevant to that software. Because if you want to consider all perspectives, it's going to be a very expensive endeavor to test it, based on all these different views. So when you ask the people, some people say, okay, let's say, what is quality? It says, I know it when I see it. Can you give me an example? When you look at the car, how can we tell it's a good quality? Yeah. Yeah, again, remember, that's a perspective we are talking about, right? Some people are interested in is the color and shininess and so on without that much concern about how often they may take it to the shop to fix, or how comfortable it is inside. So when you see it, or let's say mobile phone, look at various mobile phones, you pick one and say, I think it's good. That's it, just based on your own way of looking at it. So it's not really that objective. It's a very subjective way of stating the quality of the product. Of course, with some experience, you can, by even looking at it, after a while, you should be able to tell how good something is. For some time, I was in real estate, and then after a while, after seeing so many places, when I look at hundreds one, for example, right from distance I could tell how much that place is worth, and how much, when I got in there, how much it cost to fix it, and so on and so forth. So by just looking at it without going into too much detail, just for looking at it first glance. The same about the software, the same about other gadgets. With the experience, you should be able to some extent, say how good it is. Okay. Some people say, okay, it depends on how reliable it is. It's going to be up and running, and it's not going to go down. Some say, okay, as long as it meets the requirements, that's quality for me. By the way, what technique should be used in testing to make sure that all the requirements are met? How do you know the requirements are met through testing? There is a term, there is a that I'm looking for here. Verification, validation, and then how do you know that I have addressed all the requirements? What mechanism do you use? Remember, in large systems, you have quite a few requirements. Hundreds, thousands. How do you know all these are tested? Traceability. That's very important. Use it. It's called requirements traceability. It means for each requirement, you should be able to tell what test cases are run and how many of them have passed even. And at times they call it bi-directional traceability. The same way that you can go unidirectional, if you look at the requirement, you can tell whether or not that requirement is tested. If you have test cases for them and they have run, you can go the other way around as well. If you look at the test case, you should be able to tell which requirement it is testing. So traceability is very important at when especially once if your requirements are met. Fit for use. What does it mean? Any hands? Any other hands? Get engaged. Go ahead.
It's ready to use. It's complete. It's not going to crash on you.
And yeah, normally it means it runs successfully in its intended environment. One example that I usually like to use is that the laptops that they had developed for military during the Iraq War, they had stringent requirements of how these laptops should be, that if it drops from this distance, it's not going to break, and all this great stuff. And then after they were shipped to the war zone, shortly after they broke down. Why do you think the problem was? They had tested it beautifully. It was running great, yes. That one also was working fine. That was a problem. They never tested it for sand. Whether or not it's gonna, if you have sandstorms and all that going on, which is the case in that area, got into it and the whole thing crashed. So it wasn't fit for use in its intended environment when it was put to work. So it's easy to use. Okay, what is quality if it is easy to use? That I don't have to put too much time learning this key, that this icon, that icon. Very quickly I can go ahead and do my job. Yes. Yeah. Yes. For the actual environment that's going to be used. that is responsive, full function, it has all full function and feature, and so on and so forth. The thing is that you see so many definitions for the quality, but no matter what, in your environment, in your organization, you need to come up with a definition of the quality and just follow the whatever criteria you put down. We are going to talk about some of those later on. Now, there have been some great people in quality. Joseph Joran defined quality as fitness for use. Basically means meets the requirements, especially in this intended environment. Deming defined quality as non-faulty system. See the commonalities, we talked about the definition of the testing, and here they're looking at it. And then recently Crosby defined quality as conformance with requirements, which is about the same as this one said here. Achieve quality via prevention of errors. It says you got to build the quality into the product. Prevent all the errors. How can you, by the way, prevent the errors from occurring? How do you, no, good point, yeah, but how do you not put error in there? How do you know what the error is that you don't put it in there? From what I'm hearing from you is that when say prevention is if I do something wrong, it's not going to let me go further. It's not going to, the system is not going to bomb. It's not going to crash. What else? How can we prevent the error from occurring? Okay. Good. See, if you start collecting data, after a while, especially on the defects, and do the root cause analysis, you can say, wow, because of this reason, this problem is coming all the time. So why don't I, for the next iteration, not to make the same mistake? Let me give you an example. Let's say as you write program and you compile the program, you notice that, let's say there's a programming language that requires semicolon at the end. You see they keep on, because of the exposure you had to a prior programming language which did not require semicolon, you keep on forgetting it, and you keep on getting that error. So you collect the data, you say, okay, in this system, on this system I developed by so many of them, let's say 50% of the errors I got was because of the missing semicolon. That data, 50%. So what does it tell you? That next time when you want to write the code, you pay more attention to that semicolon, so making sure that you prevent that, basically putting semicolon in the right places. Because you're aware that that's your common mistake. Like one time by mistake I put, some time ago, these gas tanks were not as great as these days, that you couldn't put at that time you could put any kind of gas, diesel in the gas tank, in the regular gas engine. But I put diesel in my car. I messed up the engine, of course it didn't start, and finally I felt very stupid later on that by mistake I put diesel in the car. But the thing is that I learned from it, from that point on, pay special attention to any time I stop by the gas station, that's not the diesel pump. I prevented the error. But later on, even the things got better. They're preventing that type of error occurring by what? They have designed the nozzles and all that, so you cannot put the diesel nozzle into a gas-operated car. That's called prevention. You're preventing that error from occurring. And what else does Crosby say? It says you got to build the quality in. Target of quality is zero defect. Pay attention to your, again, building quality, and that's what it means. And measure success by a cost of quality. Basically, you got to have some kind of measurement to know how successful your testing or quality assurance has been. We are going to talk about some of these measures. So, based on ISO IEC 9126, the quality model, if you go there, they have defined some characteristics for the quality. So based on that standard, when you talk about the quality, you're talking about the completeness and consistency of the functions. Yeah. A good question. What happens is that as you collect the data, the main thing is collecting data, that you're going to be categorizing the errors that you're catching, and you make that available to the organization. And as you go, let's say the next iteration, let's say through lessons learned, for example, session, you can go through all the things you have learned from the past and say, okay, if I'm the supervisor for the development group, before we start the next task, so okay, let's go ahead and see how we can really address this problem so we don't come up with these anymore. So through the training, through enforcement, let's say you do the training but doesn't still guarantee that your product is not going to have that defect, but you're hoping it's going to decrease it, and as you go forward you keep on decreasing it until you get to the point that you don't have that much defect. But the main thing is you got to have data, to look at the data, to see where is the place you want to put your effort on. Because it takes time to implement some of these techniques. Yeah, questions?
One of the things that we do at work is if we find a common problem, we'll actually write it down and write what the solution to that problem was. Because it tends, if you have that common problem, it's going to turn up again. And if you have the solution already there, or at least an idea of where it's executed.
Beautiful. And many help desk systems have that feature, right? Anytime a problem occurs, somebody logs it in. As soon as you address that, you put the solution out there. So later it becomes your knowledge base. So okay, that's a similar problem. Let me see how we handle it. And that's also part of, we call it problem management. Does anybody know what we mean by problem management and incident management? Because they're very closely related to the quality management. What is incident management? What is quality? What is problem management?
Since the occurrence of the error, first occurrence, problem might be occurring.
Okay. So incident, you're saying, is the very first occurrence of it, and problem is when it's occurring?
More than once.
More than once? Okay. Any others? When we talk about now, so that was a definition from your point, what incident is and what the problem is. How do you go ahead. Incident and problem.
And then the problem is what is actually the problem. So what's causing the problem? The other, what is the problem?
You're on the right track. Yes. Go ahead. Yes, please. Okay. Very good. Yes, go ahead.
An incident, you can't really solve it. You can prevent an incident. The incident causes the problem, which you can solve.
Okay.
An incident by itself, have a problem. There's not really much you can do about it.
See, as the incident, the word implies, it's an event, something that happens. Let's say the customer is running a registration. You're registering and the system goes down, or you get the wrong result, right? That's that incident that happens at that time. And normally, when there's an incident, let me give you another example. You're sending something to your printer, and the printer printing jumbo mambo is not printing the right text out. Somehow it's messing it up. So that's an incident that has occurred. So for incident, you got to have a workaround. So what happens is I call the help desk. What they do is they come, take that printer, put another printer in there. So now it works. So they have resolved the problem, that particular problem for me by that workaround. Now let's say, again next week, another department using the same printer have the same problem. That's another incident. Again, I do the workaround. Take the printer, put the other one in. I see that that incident is happening often. So I need to do something about it. So I create, that creates a problem. Problem is that I need to find the root cause of that printer malfunctioning. So the problem is that the printer is malfunctioning. Through the problem management, I need to find the root causes of it and correct it. So the respective incidents do not occur anymore. Now, how do you do the root cause analysis again? You got to go through the expertise and so on and keep track of these, right? Keep track of the resolutions, how this thing is solved. Goes back to that keeping track of the problems we are solving and the root causes. So if the same problem comes up later on, we know how we solved it. So that's how the knowledge base, comes to picture. So going back to different characteristics of the quality based on this standard, you look at whether or not your functional, the functionality of the system is complete and consistent, reliability, usability, and so on. What do we mean by let's say regarding the quality, how do you measure these things? Let's look at one of them. Let's say we are talking about usability. How do you know that a system is usable? Suppose that's one of the criteria you want to have, right? Usable. But how do you as a tester, how do you check that the system is usable? Yes. Mm-hmm. So that's one way you're right. You are going to create a scenario for the user to see if they are going to be able to accomplish that within an acceptable amount of time. Mm-hmm. So again, depending on what type of user is going to be using that system too, right? To determine the usability of the system. And some of you have been in the usability, in the user-centered design, so you know what we are talking about. So again, something that we've got to keep in mind is that it may not be cost effective to work on all these quality factors. Depends on the system. How critical that system is and which part is. Let's say if it is a real-time system, for sure that efficiency becomes very important. What is a real-time system? That's good. What else do we add to it? Yes. So it's quite time sensitive, right? The signals are coming at the particular rate, and if you don't process that signal, you are going to lose it. Therefore, you're not going to have the appropriate result. For example, the brake system. As soon as you put your feet on the brake, then that signal should be caught and should be processed. If it's going to delay it, you're going to hit the next car at front, right? Or whatever may happen. Or in the case of aircraft, the air pressure, the speed, the amount of bank that you're making, all these information should be processed right away, so appropriate actions should take place. For example, fighter jets. They call them fighter jets versus the passenger jets. They're very unstable. Passenger jets are stable. It means if it gets into a bad storm and you let all the controls go, eventually puts itself on a level flight. But it's not the case with the fighter jets. If you're going back, it's going to go like that. So it means that's a pilot. Because of the maneuverability, the more stable, the less maneuverable. And the fighter jets should be. Now, the thing is that instead of fighter jets, they're so unstable that you cannot just rely on the pilot. The computer should help them a lot. That's a real-time system. That single movement is going to crash that aircraft. So the computer should come to the picture, and then all the data received quickly processed, and the appropriate action should take place based on that. Or nuclear power systems. These are very critical. So the point we are making is that depending on the system, you want to incorporate the right level of quality, right type and right level of quality characteristics in them. Like in the case of usability, may not apply to brake system, right? It's not visible to the system, but to the user, the code and all that interface. But it is very important to, let's say if you go to Amazon.com or some other places to order some product. Okay, so I mentioned that anytime you talk about the quality, you need to define what you mean by quality. Before you start testing, before you start doing the inspection, define what you mean by quality for that particular product, so you can do the activities to satisfy those requirements. Yes. Exactly. But that may not be relevant to that example of Amazon.com, right? Exactly. Exactly. Very good. So you need to, as you define your quality, then you've got to have some measurement to see whether or not you're satisfying. If your measurement is a number of clicks, like in the healthcare, one of the pushbacks that we have from doctors when we want to implement the software systems for them is that number of clicks. So gosh, it takes us so many clicks to order a medication. So it's the development job to see what's the best way or the quickest way that doctor can go ahead and make that order. Yeah, it depends again on the intermediate steps. If there's a step in there that are supposed to put the dose, you do not want to skip that, right? You may put the medication, but you don't put the dose, then we know what may happen, right? Instead of 50 milligrams of a particular medication, 500 milligram may be dispensed, and then is going to be creating some problems. Yeah, very good point. So depending on what we are testing, you need to define that your metric, and then you need to keep track of it. You collect the data, keep track of it, and analyze it for later use. So testing and measurements are very critical. There are some terms here that if you just go online and look for jobs, you will see that these terms are used in an ambiguous way. At least I'd like you to be aware of this terminology. I look at the timer. So you're going to give me the signal, right, in 5 minutes. I would like you at least know the right definition for these and then use them within the context as appropriate. And I'll elaborate on it. One is the term quality assurance, one is quality control. Especially if you go and look at the CMMI, which is a framework for improvements in software, capability, maturity, model integration, you will see that very clearly defined quality assurance as what we have specified here. Quality assurance means that you want to make sure that the organization is following its procedures, processes, templates, and so on. If they're supposed to use this particular template to create use cases, that they are using that template to create use cases. If they're supposed to use IEEE 803 or whatever for requirements, they're using it. All the fields, all the sections are in there, and so on. That's quality assurance. It's process-based, that the processes are followed by the organization. But quality control, you're talking about the product itself, that the product is satisfying, for example, the requirements. Testing is a type of quality control. Inspection is type of quality control, because you're looking at the product to see if, let's say again, if it is requirements based, is black box test, black box type of approach that's in line with the requirements. Because of this, anytime to decrease the confusion, let's say if I want to advertise, if I were going to advertise for a tester, I would say, if I say SQA, software quality assurance, I put a /testing. Because many organizations use software quality assurance as analogous to testing. So you're not going to put yourself off the radar if you just say quality assurance. It could mean two things, right? As I said, in terms of CMMI, it means kind of process-oriented, but in some organizations, they use it for testing purposes, for the testing organization. But please keep in mind, there are really two different things. Look at the context, look at the organization. Especially if the organization is CMMI-based organization, they have a department called QA department. Their job is not testing at all. both can be, both could be after fact, but you want to be proactive and do it prior as well. So because quality assurance, you can go after the fact. So, okay, did you follow these processes and procedures? The same about the testing. After you develop, then you do the testing. It's all mostly after the fact. But it would be it would be better if on a proactive basis, you keep on a regular basis before even the project is over, keep on checking, see if the processes are being followed. Because if they are not, let's say for the requirements, if they are not followed, they say, okay, make sure the processes are followed for the design. Don't wait until the whole project is over. Say, okay, you didn't follow the design, you didn't follow requirements, you didn't follow this and that. Okay. Let's take 10-minute break. I'll see you in 10 minutes. Thank you. Okay, so I think we know enough about quality assurance and quality control and differences between them. So there is an article that you want to read to get a better idea on software testing and the career path for software testers. You should be able to download it off the web. Any questions before we go to next section? Yes, no. Has anybody checked the D12? The first set of slides, yeah. Which is this one, actually. Yeah. Okay. Basically, the bottom line is that we cannot just create a system and hope it works and just not put time on it, not much effort, and expect the quality from it. You need to have a method. You have to have a system that you got to use to check for the quality of the product and make the appropriate changes to come up with the quality. So we talked about, again, that's iteration of what we said, what the testing is about, that checking, making sure that it works based on the requirements, and also you find any problems that may exist in there. Now, let's look at some terminology, and that comes from the IEEE. The difference between error, fault, failure. What is error? Error is basically a mistake that we make. It's more of mental activity. If I, let's say, do not know the right algorithm for a particular problem, or if I do not know the right formula, is because of the lack of maybe training that I have. That may cause some error because of my lack of knowledge. So because of that, when I go ahead and let's say program, create a code or create a design, I may make a mistake. That mistake that I make, either in the requirements, that a statement, wrong statement that I write, or right design component I put in, that's called fault. In other words, error manifests itself in the form of fault. So error is not kind of tangible until it becomes the fault. So, and that fault, as I mentioned, can occur anywhere, can occur in your requirements document, can be in your design document, code. And then when, let's say if that fault is in your code, when you reach that fault, when you execute the code and you reach that point, you are going to create a failure. You see the progression from error to fault to failure. And there are many times that since the cause of a fault is going to be the error, if we address that error, if that's because of lack of training, if you train me right, that I don't make that mistake, or don't keep on putting that semicolon in there, or I mean, not forget putting the semicolon in there, then the respective fault is not going to occur, and eventually the respective failure may not occur. And we talked about the incident. We're not going to go through that. I think we covered that enough. So when you're talking about the testing, you're really dealing with all of these. Our goal is to basically either prevent some of these from occurring, and if they have occurred, we go ahead and detect them. And then to do the testing, we are going to use test cases to test our requirement, to test our code. What is test case? Can somebody help me out with that? What are the components? Yeah, that's right. And what are the components of a test case? What should we have in a test case? Yes. Okay. Good. What else? That's important that you know the components, because later on you need to come up with the test cases for your project. So you got to know the right structure for it. Yes. The input and output from the code. Be more specific. Good. Okay, so you need to specify the input on your use case. Okay, if I give this input, then I expect to see this output. So input and expected output. Expected output. What else? That should have told you something when I told you expected output. What else should be in there? Expected versus actual. You need to show that, okay, that's what I expect. Now actually what do I get? That should be a part of your form, your format. A table basically you're going to create. And many of there are many systems out there free that you can use that, you can put your use cases in there. If I were you, I would go ahead and find some of those and use them for my project. Actually, I think I've required you to do that anyway. Yes. You can put some constraints up there, because that becomes part of the requirement that you're checking, if that's part of it. Absolutely. Anything else?
Who the user is, what their role is, and what action they're trying to execute. Then based on that, you can have an expected output.
Okay, so you want to keep track of the role, basically, the role that's taking on these activities that you want to test. Okay? If we have the expected output and actual output, what do you think the next element should be? You're comparing expected and actual. So what should you see the result? Pass or fail. You got to know if that use case pass or fail. So when we go back to that traceability I was talking about, you want to say, okay, let me see for this requirement how many test cases have passed and how many have failed. Hopefully all the test cases have passed. If any have failed, then you got to see how critical they are, whether or not you need to work on them or they should be postponed to the next release. So yes. Great. You need to have an identifier in addition to the requirement that you are testing, because of that traceability we are talking about. Now let's look at where the error may occur and faults and so on. Even though I walked through them, but the picture is worth 1,000 words. Let's say if you go through a regular development life cycle, even Agile, you really go through this, but in a shorter iteration. Still, you got to do requirement called use cases. You need to do design and code and so on, test. But an error which comes from here can cause some bad requirements, some faults in the requirements. And those faults can fit the design, and design is going to be based on these faults, probably. And then additionally, while you're working on design, that you have got some faults from here, from requirements, also you introduce more errors from here. See, it keeps on adding up. However, you can block these faults if you have good inspection or review going on here. You need to have a gatekeeper there. The gatekeeper is that inspection. So before you go to the design, let's go ahead and put an inspection gate here to inspect our requirements, making sure that we have caught those faults. So you have as little faults as possible escaped from requirements to design. I believe I mentioned that before, that the more problems you produce the more problems you have in a particular phase, eventually you're going to have relatively more defects rolled into the production. So you can always look at the result of your test. If you are getting too many errors, too many problems, it means the quality is lousy. The quality of that product is lousy. And expect having, and there is some data, if you use a PSP, if you go do the readings out there, they'll show you that one value that they look at to determine the quality of the product is the number of defects that you have found in the system. The more you have found, the more you should expect to find during the production. Okay. So going to here again, if you have design, you introduce some errors to the design as you're designing, but for those faults which have occurred in the design, have that gate here, catch them, you go to the code the same way you introduce more errors here, and then you go to the test. So when you have errors here, see the ones that are in this color are used to kind of increase the quality of our product and get rid of some of our faults. So the coding is going to go through testing. You're going to catch some of these problems, and then you fix them. Now, of course, again, you can start the whole thing over, the whole process. And here is a set of elements that you want to have in a test case. As you mentioned, if you need it, you can add more to it. So you're going to have the test case number, test case author, a general description of the test purpose. Here, I think one thing is missing that's very important is what? The requirements. I'm not saying which requirement is testing. So you want to have a requirement ID right at the top. Preconditions, we talked about test, what's input, what's expected output, what's the post condition. Let's see. I see another thing again. Oh no, here it is, expected output. So you have test input, expected output, test execution, date, person. Oh, here, that's the actual result, right? Test execution result is what you actually get. But I'm missing one item. Another item. What is that? Pass fade is missing from here. So we are catching problems with our own slides. Quality here. We are doing the review. We are using review process right now to get the find the problems. But hopefully on your version, on your notes, you put these down that we are overlooking here. You can argue so, yeah. But it would be good to make it very, very explicit, right? That actual result was this, and then the result was it fail or pass. For querying, it's going to be much better, right? Specification is our requirements. You go ahead and eventually create your system. So that's what you expect the system to do. But eventually, that's what you create. Note what has happened. That this is the only place that your requirements and actual system match. You wanted this and you got this, got implemented. It means these requirements are not even implemented here. How are these, do you think how these have come to picture? Actually, how come I have some stuff here which are not even my requirements? How did it happen? Can you give me any reasons? Yes. Yeah, we can probably argue that way as well. What else? What else can have caused it? And we are usually guilty ones. The developers are guilty ones on that part. That too, right? Somebody picks up the phone, calls the developer, say, John, why don't you go and add this one to the system without even putting it in the requirements? You haven't updated the requirements, so that got added. What else? A good point, yes. What's that called? Gold plating, yeah. That's gold plating. That programmer thinks, oh, that's the greatest thing that can be a part of the system. They're going to add it to it. Well, the customer didn't want it. The developer thought that that's a good one to have. That's gold plating. There's another one that gets added to the end. Why you have some stuff here but not here? How did that happen? You're on the right track. What else?
someone didn't complete their project.
Yeah, they didn't complete the project, right? But because of different reasons that can happen. The time constraint could be one of them, right? You're supposed to deliver next week. You have just so much to deliver, and the customer agrees, and just you deliver that darn thing without the other requirements. Budget, yeah, budget situation, exactly. Already they're over the budget. They don't have any more left. Forget about it. Let's go ahead and do whatever we can. Think what? Oh, I see. You're saying that there are some requirements here that we do not know how to implement, for example, here? Understand what that requirement is about? We see some requirements missing. See, we are saying that we have these requirements, but they are not implemented. See, what here we are referring to implementation here, not even testing, right? It says, well, of course, we are going to talk about some more when you want to test what things you may end up testing here. And how do I know if the requirements were met? Yeah, traceability helps a lot, right? Traceability is very important, and unfortunately, there are many organizations who do not really pay attention to it that much, while that traceability has great value, except for, help me out with the next part. We said what the reason is that you want to have traceability, that you know that these are the requirements, that these are respective test cases. Can I have traceability to other components of the system as well? To what?
Everything, as long as everything's clearly named and commented, it makes everything very readable. And that's really what it comes down to, just being able to read and know where your problem might be.
Okay. See, what usually should happen is that, let's say you have a set of requirements, requirement 1, 2, and so on. You want these requirements to be traceable to the respective designs. So from here, let's say requirement 1 is going to be implemented by design 1 and design 2 components. Requirement 2 is going to be by design 2, and let's say this is going to be by design component 3. The next traceability is going to be what? To the respective codes. And so on. We can have even test cases here. Now, what do you think? Let me give you some hint from the impact analysis point of view. I'd like you to think about what I mean by impact analysis. How would this traceability help us in impact analysis?
So if there's a fault, say, in D1, we would know that most likely C1, C2, and the test cases, the roots of those would be affected. So we can also backwards trace the root cause.
That's a very good application of it. You're right. Let's say if you run this test case 2 and you come across some problems, you can trace it back to the respective, because that may be the reason for this problem maybe is initiated from the design. So if you backtrack in this fashion, you can really go to the appropriate components. So what else? Yes. What is another use of this for impact analysis? Good, very good. What about if the client comes back to us saying that they want to make some changes to requirement set 1, R1? How would something like this help us? So how do I know how long it's going to take me to make that change to requirements 1? Unless I know how many design components may be impacted, how many code modules may be compacted. So this one can give me for estimation, estimating how long it's going to take or how much it's going to take to make that change. Good job. I'm proud of you. You're doing a great job. You need to, you got to probably, I'll give you the final example, and we call it this term. So we looked at this one. Now we have added the test. Tested. How do you, what does it mean? Can you talk to me? What does it mean? Let's say, okay, what is this area? Area number 5. It means that, well, it doesn't really tell us whether or not it passed, right? All it says that I tested here means that, what does it mean? This area is all the ones in the requirements, right? See, that's a specification, that's implementation. So it means we expected our system to have these requirements. And then eventually we implemented these, like the previous one that we talked about. Now, at this point, I'm testing everything was expected and also was actually implemented, right? So I'm testing those. Now, how did this one come to picture? 4. Yes. Go ahead. Let me take some from here. Somebody, I heard some. Somebody, nobody? Please, go ahead. See, these are the test cases, right? Test cases. When do you write the test cases? When? After the requirements? But normally, when is a good time to start writing your test cases? When all the requirements are complete? While you're working on your requirements? See, you're killing two birds with one stone. I don't want to say kill. What should I say? Okay. So you're addressing two things at the same time, right? One is that you want to start your test cases when you start while you're working on your requirements, because as you mentioned, one reason is that the customer says something about the requirement, but it's not testable. How are you going to be testing it? You're going to ask questions, making sure that the requirements are testable requirements. If the customer says, I want my system to be usable, what does it mean? So we're going to ask questions. I want it to be efficient. What does it mean? So what happened, again, these test cases came about while we were working on the requirements, but it happened that they were not implemented, as you mentioned, later. So we cannot test them. What about this? So when do you think these test cases are generated? Yeah, because here you should know something about the implementation to write the test cases for it, right? And normally, is this one black box type of testing or white box testing? Is white box testing, because we're looking at the implementation again. Oh, we talked about the black box and white box. So tell me then, what do we mean by white box? What do we mean by black box testing? I guess we talked about that before too. That's black box, right? And white box? Actual inside, you're right. With the black box, you do not know what's going on inside the black box, inside the software. All you know is that, for example, I want to find the average of two numbers. You don't know how that averaging takes place inside the code. And the white box is usually based on the requirements. You take the requirements, you come up with the test cases, and you test them. That's a black box testing. And white box is when you really dig into the module. You see all the loops, or you see all the methods, you see all the structures. And you write your test cases based on that structure. So, well, here we talked about, again, you got to create your test cases using the form that we talked about. And also you need to keep track of when you execute your test cases, you need to, when you find the defects, you need to come up with the priorities of these defects. Why do we have to prioritize our defects? What do we have to know if it's a priority 5 or priority 1? Let me, before I go to here, let me give you another example, which is to some extent also related to the incident and problem management. At one of the companies I was working at, I put the process together for problem management. And then for each problem, we cannot address every single problem. There's so many of them. It's not cost effective. So you need to come up with, okay, this is the most important one, this is the second level, that's the third level, and so on. The way that we put them in the priority order was by the amount of impact. It was a lottery industry. And you know that each state usually has contract with normally one vendor for, let's say, online lottery. And so many different terminals are connected from these convenience stores, grocery stores, and so on, connected to the system. And actually, as part of the contract with most of the states that we had the contract with, we were penalized $2,000 per minute when the system went down. So it was a hefty penalty. So we had to make sure that's a good quality system. So when something happened, the way that we prioritized that, let's say, incident and later on problem was based on the number of terminals which went down. If that problem caused all the system to go down, it must have that one had the highest priority. It means it had to be addressed like this right away. And then if it, let's say if it impacted, let's say 25% of the terminals, then the priority went down. Keep on going. If it was just one convenience store which went down, it was a lower one. So we didn't put all our effort on that particular type of activity. The same way with the defects. When the defects happen, the problems happen with the system, you need to see which one you should put the time on, which one you should spend the effort on to correct. And that's why you got to put them in some priority order. Like different organizations have different ways of doing it. Like in this case, we had 1 through 5. 5 meant all the terminals, 4 meant, let's say, 25% of the terminals down, and so on, all the way to 1. Here is another way that you may say, okay, I have very high severity defect, and you define what you mean by that. Here the definition is that brings the systems down, or a function is non-operational and there is no workaround. The whole thing is down. That's the highest priority in this case. Or the high severity is a function is not operational, but there is a manual workaround for it. It's not automated, but there is a way that you can manually take care of it. And so on. The next level, a function is partially operational, but the workaround can be completed with some work. But the work can be completed with some workaround. And finally, low severity, minor inconveniences, but the work can be completed. Maybe system is a little bit slow, but the work can be done. Then we look at it later, why the system got a little bit slow. Was it the database overload or whatever may have happened? That's another classification by Beiser, another person. So I'm not going to go through all these, but I want you to get an idea that depending on your software, depending on your organization, you want to categorize these as they apply to your environment. Like this one, the very highest one, let's see. And that's the lowest one, I think, right? That's the highest, right? Shut down that spreads to others. Then mild is misspelled word. It's a mild bug, and so on. Annoying, disturbing, serious, and so on and so forth. Whatever you use here, you may use 1, 2, 3, 4, 5, 6 all the way down. This is important to put this on the right, so we know what each of those means. Now, again, IEEE has a list of faults, like input-output, faults related to input and output, and so on, logic faults, and so again, we're talking about the categorizations that you don't have to reinvent the wheel. You can go ahead and take some of these and use them. There's absolutely no reason to find your, to come up with your own way of implementing quality systems. Different levels of testing. You see some terminology here. that may be different in your company, was different in the companies I was working at. Each company had its own terminology. But some of them are in common. You know, like anywhere I went, or unit testing is unit testing. I haven't seen any other term for it. That you take basically each module, a method, or whatever, you test it to see if it works. But from that point on, you see different terms. Let's say in this case, in this particular example here, anytime you put a set of programs, you create a function. So a function in this context is a set of program units. So in this case, what? They have two program units, A and B. They created function 1. So you need to test that to see when you put these two together, whether or not they work. Maybe some organizations, they want to call it interface testing. But whatever it is, define what that type of testing is about. What is it supposed to test? If it's the interfaces that you want to send the data back and forth among these components, making sure that they're working correctly, define it as such. You want to call it functional, call it functional. But define. Then the next level is component testing. A set of functions gives you components. And then finally, in this case, system testing. Of course, there is some more. What other testing do you think is coming after this? Yeah, you can. Yeah, you want to put it in. If by this again, you need to define it. If by this one you mean your system per se, and then you want to see whether or not it interacts with others, sure, you can put it at this level. And then what is next after you do the? It may not apply to you. You may not even think about it because, as you mentioned, yours is internal, right? But this is normally, even in your case, there should be some kind of user acceptance testing. It happens that you basically throw it over the wall for the internal user, but still the internal user can be considered as a user that can do the acceptance testing before they accept the product. So it's called UAT, user acceptance testing. Then if they accept it, they go through their own test, the users go through their own test, and then you can put it in production. Who do you think does this kind of testing, unit testing? Programmers. Who does functional and component testing? Still, normally programmers do that because it's more of very technical. They're still looking at inner workings of the system. What about system testing? Normally you have an independent group. A testing group is important that that testing group is independent. Otherwise, it would be conflict of interest. If the developers test their own product, it's always fine and dandy. So you want to have an independent entity. And best practices in the standards, they require that if you have a testing group, it must be independent of the development group. Because normally they should be able to sign it off, go, no go. If it's a no-go, the software is not going to go anywhere. It's got to go back and correct it. Who does the user acceptance testing? The name implies. The user does it, yeah. So let's say you are the testing organization. You got to show your value to the organization. You shouldn't be just they call it, you shouldn't be cost center, just a group of people who are just taking money in, spending money, and they are not creating any values. How can you show your value to the organization? What's the value of the testers?
You don't necessarily need someone who knows a whole lot of code to do testing, so it frees up those people who coding. Someone who might actually cost more to employ on their rate.
That's good. You can put that number on the spreadsheet, right? How much the company is going to save. That's one. Very good. That saves money by having testers versus putting the developers doing the same.
How many errors were found?
That how many errors you could find and fix before you put it in production. How do you add value to here? What would the value of it be? Okay, so what? To decrease the number of errors. So what? Go a little bit further. So what will happen if you have a better quality product rolled out? So it means your company can stand out better against other competitors. Your system, especially these days, hasn't it happened? You go to a website, you're looking for something, it takes you 30 seconds, you just, I don't want it, you go to another site. So you have lots of customers like this because of the low quality. Yes. Yeah, you can quantify that. You're right. Say, especially if you're keeping track, you got to keep track of it. So you got to keep track of it. So you can say, if we are not caught, what kind of maybe financial impact or reputation impact would have had on that customer who is using our system? Again, you should be able to somewhat. The more you quantify, the better position you are going to have. Actually, who has heard the name Sum14? Who's Sum14? He died about, I guess, 3-4 years ago. In what area? Where was he good at? He was called, anybody? Yeah, he was called the prophet of process improvement. Yeah, he was behind the first version of CMM, capability maturity model. He project managed that. He came up with quite a few books, one on PSP, personal software process, team software process. He was very data-oriented. If you look at the books and the approach he takes, he looks at data. He says that if you go to the management, let's say you're assigned to development of a software project, then you go to the management, you say, okay, this is going to take us, let's say 6 months, well, a year, and $5 million to do it. Now, if you have data to support, if you don't have the data, just you go there, so it takes you a year and so much, it is your words against the management. Who's most likely to win? Management, because you don't have anything to support it. But if you have data in your hand, you have much better chance of winning that argument. Even though if you don't win it, later on, if you are forced to do the project, later on you have the data to support it. I told you so. So the data is going back to the discussions we have had. What's your value? You got to have a good data to show that. For the value of the testing. We can go through some of these items and now we want to. The question is how much should we test? How much should we test, by the way? I guess we answered that a little bit an hour ago. How much should you test? When you know you're done with testing? It's perfect. Okay. You know that we cannot ensure that. So what are some of the elements, reasonable elements, criteria that you can use? Anybody else? That could be, after a while, you should have, excuse me, some data of these ratios that in a regular development life cycle, normally what percentage of the effort should be given to requirements, to design, to testing. And there are some industry data as well that we can look at. So if it is, let's say 20% for testing, you want to spend about that much for testing. What else? Yes. It's working. It's still blinking. You're saying about, let's look at the components that have maybe more value, or the components that are most likely to fail. And let's focus on those areas. Where is going to add more value, right? Just focus in those areas and test those particular components. I thought I saw your hand too. Anything else?
Also, when you do your testing, really can, as long as the higher priority errors have been resolved, then you might move on.
Yes. So you want to make sure that all the requirements, that's good. That's good measurement, because for each requirement you have a set of test cases. You want to make sure that, or at least, well, let me qualify that. You want to make sure that all the requirements are going to be tested and tested with success. Okay. Even the requirements have priorities. It goes back to the components we are talking about. Even requirements have high priority requirements, medium level requirements, and so on. If you ended up implementing, let's say, 3 levels of requirements, very high priority, medium, and whatever the next level is, probably it would make sense saying, okay, I want to make sure that all these 3 levels are tested successfully, and the other ones, even if they are not tested, you may not have that much because of their priorities. Again, remember, you don't have unlimited. These are the decisions that you got to make. See, we are considering all these possibilities. You don't have unlimited amount of money and time. Based on that time, and unfortunately, that's a testing that's cut short. development normally, let's say even though you have assigned, let's say 1 month for testing, what happens is that the development takes up maybe another 2 weeks of your time, and all you have left is 2 weeks to test. So you need to decide, okay, how can I do my best of rolling something which is going to make sense?
Okay, just a minute. But yeah, compromise on the testing time. And you said if I want to compromise, I want to test everything. The implications of it later on will be so much worse.
And that's why it goes back to the pros and cons. You got to see, you're absolutely right. That's the ideal situation, that you test all the requirements and everything else. But because of the constraints that we have, the time and money constraint, we have to cut short somewhere. And you need to decide if you want to look at the priorities of these requirements, that you know that those lower priorities are not going to have that much impact on the customers. Maybe you can leave them to the next release and let them know that we are going to test them slowly during the next release. But now, because of, since they have promised the world, let's say that's a software, it's a package you're developing, Apple or I don't know, Microsoft and so on, that promised the world to deliver that, let's say, next Monday. So they got to deliver it. So you got to do your best of checking it for the quality as much as possible, but no matter where it's going to go. The senior management is going to push it out. So with that limited time and that you have, you need to, the group needs to decide what is the best, most critical aspect of the software that needs to be. Again, we are looking at the reality. Ideally, yeah, it would be great to test every single thing. Any other devil's advocate? These are great discussions we got to have, because these are going to happen in real life. We cannot always do the ideal things that we like to. We need to have, we have to cut short on some of the areas of the testing. Like even though I'm saying that the inspection and reviews are most effective way of checking for the quality or creating quality software, the organizations should not do that, even though we know that it's most effective. Any other? Yes. Comment? Mm-hmm. Again, that's something you need to see how much effort you want to put on one against the others. Something also we need to be aware of is that bringing in automated testing is not cheap either. Many of these automated testing tools are very expensive, requires lots of training, requires lots of time to create use cases. So you got to see which one, are you ready to invest there? If it is something long-term and you're going to do, especially as you mentioned, lots of regression testing, that's going to take lots of time and effort, then maybe something you want to do, go ahead and automate as much of it as possible. And see which parts, as you mentioned, should be manually done, which parts should be done in an automated way. Yes?
Why do most people just put everything in the front page?
They export the errors?
Yeah, you can actually have the program itself trace through itself by just including everything in the try catch.
Okay. Why not? You say, why do you think we don't You basically have the log of everything is happening, you are saying.
Seems like different areas of not extremely profitable kind of high critical might affect the system more. May not be as important as during testing, but it's not going to affect that large population during testing.
Mm-hmm.